Welcome to a four-part series to give you an introduction to both Lean and Six Sigma. If you have registered for our Lean Six Sigma White Belt certification course, you will receive a Lean Six Sigma White Belt certificate once you complete all four modules and pass a final exam. You will see a link to the registration at the end of this course. My name is Kevin Clay, and I will be your program leader for today. Let's get started. Let's briefly go over the course agenda for this module. I'll start out with an introduction to both myself, Kevin Clay, and our firm, Six Sigma Development Solutions Incorporated. In this module, we will be discussing the 7+1 deadly wastes. Before we cover the wastes, I will show you a video. This video will show you how aware you are of your current environment. I think you will thoroughly enjoy this video and the result it will have on your understanding of waste. Let's move on. A question you might be asking yourself is, who is this gentleman instructing us? What are his credentials? Well, excellent question. My name is Kevin Clay, and I am the president of Six Sigma Development Solutions. I am a Six Sigma Master Black Belt and a Lean Master Practitioner. I use the word master lightly because I truly do not think there is one. I find that the more you know, the more there is to know. It is a never-ending learning process. On this slide, you might see my email as well as my personal mobile number. If you have any questions about any of the topics that we cover in this course, please do not hesitate to email, text, or call me. Myself and my colleagues pride ourselves as mentors and teachers that are available to answer your questions. I have had the benefit of being a Lean and Six Sigma practitioner for over 17 years. In these 17 years, I have gained operational experience in many different disciplines. Disciplines such as manufacturing, distribution, processing, finance, retail sales, insurance, healthcare, IT, nonprofits, local and state governments, and many national governments. Myself and my colleagues have experienced many different processes and cultures. This makes us very effective teachers, mentors, and consultants. I have personally instructed over 500 plus change agents across the many disciplines that we have just discussed. I've led over 15 implementations in both domestic and global organizations. I have led or mentored over 80 Six Sigma industrial and transactional projects and facilitated over 110 Kaizen and workout projects for industrial, service, and healthcare environments. How do these credentials benefit you as a student? When my colleagues and I teach the Lean and Six Sigma methodologies, we back up these concepts with real-world stories of how these tools actually work. Comments on our course evaluations follow a consistent theme. These comments basically are, it's like you've been in my facility and you know my organization's problems. Well, we may not have been in your facility, but we have seen many processes with the same issues. Okay, so let's kind of move back into Lean and talk about the 7+1 waste. A lot of people call this 8 waste. I call it 7+1. My colleagues and I call it 7+1. The plus one is really a more recent waste. It's called underutilization of talent. And then the 7 original wastes. Okay. So the first waste is overproduction. Overproduction and early production. this really happens in three forms. All right, overproduction and early production can happen in raw material or raw information that we have supplied to the process, to make a transaction, to make a widget, to make something. And make no doubt about it, I often get this argument in class that, you know, I'm in banking, I'm in insurance, I don't create a widget. You absolutely do. You create a service, you create a transaction, you create something. While it may not be with steel as raw material, as wood as raw materials, as plastic as raw materials, but it is, you do have information, you do have forms, you do have databases, you are creating something. So again, this overproduction can happen in the fact that we have a lot of stuff that we have sitting in wait to make the product. All right, we have a lot of paper, we have a lot of information, we have a lot of databases, we have a lot of this complexity out there sitting in wait to make something. All right, and that stuff could really cost us a lot of money. Okay, so we have all this stuff we're using, and that stuff we call inventory. All right, inventory is basically something that we have that the customer has not ordered yet, or things that we have in place waiting for the customer to order. We're predicting a demand. So as far as raw material, let's say that I in prediction of a demand, go and buy $100,000 SAP system, and I know SAP costs a lot more than $100,000, but some computer system to manage my process in prediction of this demand, and the demand doesn't come quite like I think it would, quite like I think it did, or I'm sorry, quite like I think it was supposed to. It's much less of demand. All of a sudden I find out that maybe I didn't need that. Maybe I have all this information. Maybe I'm about to give a report out to stakeholders, and I think they're going to want all of this information that I'm going to spend some time reporting out to them. But I go in and they only want 5 seconds of something very menial. Again, I'm wasting my time. All right, so overproduction can happen in the kind of the raw material, raw information to create something. It can happen in the process of making something. All right, so again, I create all this stuff in prediction in my process to create something at the end. Again, that is in prediction something. So I'll give you an example. If my customer requirement is, when I call, I want you to, when I order a widget, I want you to send that widget to me within, I want it to be created and put on a shipping implement within 24 hours. Now, they're not going to say created. They just want it, when they order it, they want it sent to them within 24 hours. What if it takes me 3 weeks to make that widget? How do I supplement for that? How do I meet the demand of that customer? Well, I have to have a crystal ball. I have to understand what that need is before the need's created. So it's called forecasting. And most of us who know people that forecast, most forecasters forecast plus a certain percentage, because it is a sin to under forecast. If I under forecast and all of a sudden I don't have what my customer wants, then they're not gonna get it in 24 hours. They're gonna have to wait that 3 weeks, and in that case we might lose the customer. So it's better to over forecast. Now, if I constantly over forecast, then what am I left with? I'm left with all that overage, right? And I have to put it somewhere. I have to store it somewhere. Now, most companies will tell you this. Well, we'll sell it eventually. I go into companies that have racks full of stuff that have been there for 1, 2, 3 years, and those racks full of stuff get counted. They might get counted daily through. This is a manufacturing example, but cycle counting. They might get it counted on a daily basis, or maybe one time a month. And they also get counted in physical inventory, maybe 2 a month, or 2 a year. So I'm being counted over and over and over again. A lot of times I'm being moved quite a bit. All right, maybe I'm lost. There's all kinds of things that can happen to me. But over time, well, what a lot of financial people find out is when that thing gets sold, because it is of the carrying cost, it a lot of times has no value. It could even have negative value. So we call that overproduction and early production, which equals inventory. We call that risk, right? Because it has the risk of all of these things. So let's get it back into inventory. So inventory is that risk. Again, something that the customer hasn't ordered. A lot of times we build this inventory in prediction of something. And how many times does technology change, and all of a sudden what you have in inventory it becomes obsolete? Think about those Dell computers. Think about any old PC that all of a sudden some new technology comes out. Think about a service or a transaction, a banking service transaction. Think about a hospital service that all of a sudden something new comes out, some new technology, some new way of dealing with a disorder, disease, and we've stockpiled these medications, we've stockpiled this equipment, we've stockpiled this way to deal with the old way of doing things, and all of a sudden, guess what? Out the door, they become obsolete. Again, we're predicting that demand, and after a while, we build up that inventory. Some other ways, waiting. You saw that in the video, first data video. You saw things waiting. You saw things that were sitting in wait. Those transactions sat there for a good part of the time. About 99% of the time, they had nothing being done to them. Transportation. You saw that things were being moved in between silos. Transportation can happen between desks. Transportation, I've actually seen two people sitting next to each other with a cubicle dividing them. And I send a form or a transaction via email to that person, and that email goes out into the interweb, into the neversphere. All right, it sits out there, and it travels and it waits. And it waits for it. I saw it wait for 2 days before it got transacted. It didn't move, but maybe physically in the physical world, it moved not even a foot. But in the digital world, it moved an infinite amount to get to that other PC. I've seen companies. I've seen a pallet for a processing company move 2,500 miles in the same state and never get sold. Move between distribution points. I have seen purchase orders that move between seven different sites in a municipality in a city that it takes 15 minutes to drive from one end to the other. I saw it take 3.5 weeks because it moved in between these areas. Again, different buildings, different sites all over the city. All of that's transportation, and somebody has to pay for that. All right, more than likely, in a for-profit company, the company has charged what the market will bear. So the customer in this case is the internal customer, because they have to pay for it. But eventually, the external customer really has to pay for that because they have to wait. Then when we get to motion, so motion is a little different than transportation. Motion in industrial environment is really, if I'm building something, if I'm creating something, if I'm at a workstation doing something, making that widget, and then I have to move away from that station to grab things. I have to bend over. I have to reach up. I have to do all these things that are taking you away from creating value. That's called motion waste. Because all the time, again, as I'm moving away from my process, I'm not doing my work. I'm not adding value to the product. All right. So and in industry we use what's called the 30-second rule. I should never really have to move away from my process 30 seconds. We also use this term, that's used everywhere, ergonomics. I shouldn't have to reach up. I shouldn't have to bend down. I shouldn't have to turn around, because over time, what kind of a toll does that take on your body? It has a huge toll on your body, and fatigue. So a huge waste that is done, within a lot of organizations, even within transactional. So I usually get this from my students who are in a service process, and they say, well, I'm sitting at a desk. I get up to get coffee and all of that, but I don't really commit motion waste, and we don't create things at I got to keep creating things at one every couple of minutes. Ours is more of a cognitive process. So I say, well, you have to make decisions, right? That's part of what you do, make decisions. So if I've got to make all these decisions during a day, and let's say one of the decisions I have to make, I make consistently, and to do that, I have to go into a portal, some of the customer sites, so I have to sign into their portal, and then I have to pull up a SharePoint database and then search for a file. And then I have to pull up a financial database and look in that. And then I have to pull up an Access database that IT's created. And then I have to look into a Excel spreadsheet that I've created. And I'm looking through all these things to make a decision. What am I not doing? While I'm doing all this stuff, what am I not doing? I'm not making the decision, right? That's called motion waste. The time I spend searching, I'm not making that decision. So in service as well as industrial environments, we do the same thing. Overprocessing. So let's talk about that. We saw two types of overprocessing in that first data video. All right. One of them was the fact that every time we went into each of these silos, we sorted differently. All right, and again, that's because each of these silos are their own little kingdoms, their own little fiefdoms, their own little cliques. Another thing that we saw was what's called routing sheets. You saw that we had these things that we filled out to kind of track the process, to kind of track the transaction through each of these steps. Well, we have this. We have this because we have such a long process. Now, does the end customer see these routing sheets? Absolutely not. All right. This is only important to the internal business. This is so that we can track our process. Now, what's funny, during this solving this, you had a lot of people that said, well, we have to have these routing sheets. How else are we going to know where the transaction is throughout the process? We can't get rid of it. That's called fixed thinking, and that's the enemy of lean. All right, so in lean, we really have to get into that, not how it can't be, but how do we make it? And these methodologies of lean help to get us there. Why is that important to you as a white belt? Because that you can't be that enemy of lean and say, well, we have to have that. All right. Think of ways we can get rid of that complexity, and why lean is so important, and what's so great about lean is if you can stick any of those steps within these 8 wastes, then those steps are waste. And our job, your job as well, to collaborate with those change agents is to say, okay, now that we understand what is waste, now how can we get rid of as much waste as possible? And that routing sheet was obviously waste. The customer doesn't care about that. It's over processing. Defective units. I'm not going to talk a lot about that. We all want to know what defects are, things that don't meet requirements. But defects really they lead to rework. They choke the process. They cause things to happen 2 and 3 times. So again, that rework. And this is really best dealt with Six Sigma, because lean just cares about whether you kick through the goalpost. If you remember that analogy, lean just cares whether you kick through the goalpost. What lean doesn't understand is capability, and how capable am I of splitting that goalpost every time? Because remember, when I asked you, of those 5 kickers, which one would you pick? And you said most people say the one in the middle. Lean doesn't care about anything. It doesn't care about that one in the middle, because lean says all 5 of them are good kickers. All 5 of them, I would pick any one of those 5. All right, because lean misses that concept of capability, and when it deals with defective units, lean is not the best way really to deal with defective units. Six Sigma is a far more optimal way. And then we get down to the last waste, underutilization of talent. And the best way to explain this is, in that first state of process, there were, again, 12 steps in the process. Each person did their own thing. They had the one thing that they knew how to do. All right? And I don't know how many of you have ever heard this from an employee, but if you've ever heard this where an employee says, nobody can do what I do. I'm indispensable to this company. If they lose me, they will be hurting. All right? That is one of the worst employees you can have. And that is really created by management, okay? Because no employee should hold power over a company. I was a plant manager for a company, and one of the mandates was that all of our employees will know multiple jobs. And actually, we had our employees. We didn't have employees that worked at one job every day. We had employees every week. Our employees would switch to a new job, would switch to a new station. So that helped us to cross-train them, and it also helped that employee to stay current on that job. Now, we had quite a few employees that were very mad about that, and that eventually quit, and that's normal. All right. So by doing this, all of a sudden we started utilizing the talent of our employees better. In lean, an employee is not really considered an employee, but they're considered dynamic capacity. So if I've got an employee that is working in a job where only 40% of their capacity is being used, then they have freed up capacity. Now, if I have another step of the process where somebody is working over their capacity, I could cross-train that person that's not working to their capacity to then flex. It's called flexing. So flex over to that other job to then release that burden on that person. So all of a sudden, it's moving employees around like pieces of a puzzle, almost like chess pieces, so that we provide a more optimal process, right, by moving their capacity around so that we optimize everybody's capacity. And that again is amazing transformation. I go into a lot of places where the first thing I hear from employees is we need more people. From a project that we're working on, in a process that we're working on, after 5 days we leave, and all of those people go, wow, we had so much hidden capacity that we can increase our production by 2 times and still not reach our capacity. So just by moving those pieces of the puzzle and optimizing that capacity. So these are the 7+1 ways, the 7+1 mudos. As a white belt, this is one of the most important things for you to know. Again, because in a Lean and Six Sigma or Six Sigma implementation, your job is really to start identifying these. And once that formal structure has been put in place where you identify those, given some form, given some digital form, and those being vetted, and then turned into a project, all right, for then you to be a part of getting rid of or reducing. This leads to amazing transformation of a company. Now, what I would like to help you to do is to get an understanding of how aware you are of your current environment. At the core of Lean Six Sigma is understanding our current environment through visual signals like tact and anon boards, also through solutions like control and capability charts. I'm going to show you a video on the next slide called the Lean Awareness Test. This video is of 2 teams of 4 people. Each team has a basketball. Each team will be passing the basketball to other members on their team. One team is wearing white clothing and the other is wearing dark or black clothing. What I would like for you to do is to count the number of times the team wearing white clothing passes the ball to another team member wearing white clothing. The narrator on the video will inform you of how many times the ball was passed. I want you to compare your numbers with his. Let's watch the video.
This is an awareness test. How many passes does the team in white make?
Go!
The answer is 13. But did you see the moonwalking bear?
So let's kind of go into the 7+1 way. So let's go in more detail, just kind of recover it. So again, overproduction, producing more than is immediately needed. Again, overproduction can happen in raw materials, can happen in raw information, can happen in work in progress, or whether I'm making a widget or a transaction or service. All right. If I have an unbalanced process where I'm pushing stuff through, that's going to cause a lot of chaos in the process. If you remember that equation, my lead time is equal to the amount of WIP I have in the process over the amount of exit rate or the rate at which I exit. The more that I have WIP, twice the WIP going in as exiting, all of a sudden I have a bottleneck, I have chaos. All right, this really drives waste in all other areas, overproduction, and a lot of times we overproduce because we predict a demand. We predict that something is going to happen. So because our lead time to make the product or service or whatever is longer than the customer's lead time. So again, get back to that. When I order it, I want it in 24 hours. But if my lead time to make it is 3 weeks, well, then I have to have a crystal ball to know what's going to happen, 3 weeks from that date. And so therefore I build inventory. And most people know that companies that build inventory, it's better to over forecast than under forecast. Because if we under forecast, then we're not going to have the product for the customer, and they're going to have to wait that 3 weeks, and we don't want them to do that. So we over forecast, and what happens is that all that stuff that's left over, well, we got to put it somewhere. We got to put it somewhere. We got to count it. We've got to account for it. This ends up taking up space, whether the space be on servers, whether the space be in warehouses, but it starts to build clutter and chaos, and this stuff leads to bad morale in our work areas. So this is an example of overproduction. This was actually in a order processing center that was the first step before something could get manufactured. So the customer calls in, orders a product. Their lead time was 3 weeks. The production lead time is 3 weeks, and that's including this ordering process. Well, there was so much of a backlog of orders that the order process took anywhere from 3 days to 5 days. So basically a week of that lead time was taken up in just the paper sitting there. When we actually did a value add analysis, we found that it only took no more than 1 minute to put the order in, but it sits there for almost a week. So we went in and we helped them to understand how to prioritize their critical processes, how to balance their processes. They had a lot of capacity within all the order processing center, but they were all working in silos. And because of this push process, because of this unbalancing, it led to this huge backlog. Today, the order comes in, and it takes no more than at max 3 hours before it's put into the system. So another waste, defects or rework. All right, I'm not going to talk too much about this because really Lean doesn't deal as well with defects as Six Sigma does. Lean just says kick through the goalpost. As long as you kick through the goalpost, you're good. All right, and hopefully we all understand now that that's not true. That we need to understand our capability of kicking in the center of the goalpost. we don't ever want to get near those goalposts. We want to split the uprights every time. Defects. How does it affect our process? Well, in lean, it causes lead time, because all of a sudden we have something now that's a defect that we have to do one of two things to it. We have to either scrap it, get rid of it, all right, which basically we spent time and money and resources in building that product up to that point, building that service up to that point, building that transaction up to that point. But now we can't do anything to it. So we have to go back. We have to go back and either rebuild the product, service, or transaction, or we rework it. So let's say that we can bring it back to a certain step and rectify or mitigate. Rectify the mistake we made. Still, we're doing things 2 and 3 times. All right, so defects really chokes the process. Transportation. We talked about transportation, putting sequential steps. Step 1 and step 2 being far away from step 1. The far away could be 20 steps, but it's 20 steps that I have to take to get into another silo. It could be down the hall. It could be climbing 4 flights of stairs to another floor. It could be in a different state. It could be in a different city, a different country. And the farther away that our next step is from us, the more we tend to build a batch, because it doesn't make sense for us to pass off small batches if something is in a different country. And I often get the question, but I send email, I send digital transactions. We have an SAP system, and I communicate with India, send stuff to India, and they send it back to me. But again, transportation is really that digital transportation. I'm still sitting in a queue. I'm still having stuff pushed to me. All right, and a lot of times that queue, the farther the other process gets away from you, that queue is actually fed by a number of queues. So I've got 10 or 15 different people feeding that one queue. So again, that the farther the process is from the preceding process, the more waste tends to build up. Waiting time. All right, this is really what your process tends to do. Okay, we usually find that over 99% of a process, of a product, 99% of a product, a service, a transaction, a patient tends to 99% of that is time that they just sit and do nothing. They're just sitting there. Think of a patient in a clinic. I've got a sinus infection. I come in and sit in a clinic. I first go up and sign the paperwork, etc. I'm told to sit down and wait. I'm then called to the back after being there for 20 minutes, 30 minutes. I'm called to the back into a room. I then sit and wait in that room. Eventually, the doctor comes in, sits with me for no less than really about 2 minutes. He then leaves. If there is a place for me to get my medications or my medication within that clinic, I then go to the medication center, give my script to them, sit down and wait again. And then when they call me, pick up the medication, and I leave. If you really look at that whole process, very little waiting. Very little value-added time, a lot of waiting. So I could be there for 2.5 hours, but only really about maybe 5 minutes of actual value has been added to me. So again, waiting for other people, shared equipment. We see that. I see this a lot in a lot of processes. We micromanage the process. Instead of understanding why the defects happen, we all of a sudden add more approvals to it. So the more the process creates problems, the more times that we have to vet it. Having operations that are not balanced, that's usually when you're going to have people just sitting there waiting because they're waiting for an upstream process. So a lot of things can cause us to wait. We talked about motion. We talked about motion in two different arenas. In the industrial arena, when I'm making widgets, anytime that I have to move away from making that widget, what am I not doing? Well, obviously I'm not making the widget. So you accumulate that by all of the people that make the widget, and you start to look at the non-value added time of people moving away to grab stuff or to do paperwork, etc. And the time it spends to make that widget. It's amazing the actual amount of value added. Also, we have a lot of times. I go in a lot of companies and they're working, time and a half, double time, working weekends. People just working their tails off 7 days a week, and that's really how we deal with this, right? We remember the equation: lead time, the cycle time, is equal to WIP over exit rate. So in most companies' way of dealing with this imbalance with this throughput that they're not getting enough of because of these wastes I'm telling you about, they add more people, they add overtime, they add double time, all right, which has a huge hit to the bottom line. There's also motion. Again, I'd said, in service, I get a lot of people say, we don't make widgets. We're not making products. And I always have the argument with them that you're exactly making a product. You're exactly making something. While it may not be a widget, it is a service, a product, or a transaction. And when I sit down at my computer, when I sit down at my desk, a lot of times I'm there to make a decision, to provide information to make a decision. And the more time that I spend searching for the way to make that decision or the information to make the decision, the less time I'm making the decision, right? So when I go out to customer portal, I go out to SAP, I go out to a time and attendance program, I go to all these different solutions to make the decision. I'm not making the decision, so that is also considered motion and waste. So we all do this. And then inventory. All right, I think we understand what inventory is. Again, inventory can happen in raw materials. I a lot of times deal with industry that they have something called EOQ, economic order quantity, where buyers go out and they get a price break for buying something in bulk. All right, so that thing comes in bulk. It has to go somewhere. All right, so it has to go and take up floor space. Again, it has to be counted. A lot of times, counted a couple times a month. Counted during physical inventory, and I can tell you that most of the companies that I've gone into, I've helped them understand through some mathematical models that I bought something on economic order quantity. It's been in my facility for for 6 months. When I take the price break that I got for that product 6 months ago, all right, and then I accumulate all the stuff that I've done to it over that time, the carrying costs, moving it around, cycle counting it, inventorying it, and I accumulate those costs, I find out that the product actually costs more the day that I use it than if I was to go out on the open market and buy it at the normal cost, not the price break cost, but the normal cost. And this I often say during my class, common sense is not very common. And to even add to that, and a lot of materials buyers are going to cringe at this because this is kind of an unknown fact, and a lot of them don't want you to know it. They get bonuses for buying things on a price break. A lot of people get bonuses for being able to get a product, a raw material on a price break. But in reality, once that product is used, the day it's used, it actually a lot of times costs more than, again, it would on the open market. So lots of inventory in raw materials, lots of inventory in work in process, again because of unbalancing. Lots of inventory in finished goods because we predict something is going to happen. Okay, and then we get to overprocessing, and this is really doing more than the customer really wants. Well, a lot of times that's because we don't understand what the customer wants. We make a judgment as to what they think they want. All right, so overprocessing could be giving the customer unneeded complexity. I'll give you an example. I ran MIS for a company for a couple of years, and I had programmers that were under me, and the programmers would build these modules, build these forms, build these different solutions without really understanding what the customer wants. So you would have these programs that there would be fields in a form that were unneeded. We didn't need to fill these certain fields in a form. That there would be certain functions that nobody used. But these programmers spend a lot of time building that. So by not understanding the voice of the customer constantly, by not constantly understanding the voice of the customer, because that voice can change, and it does change. You snap your finger, and the voice could change. All right, so we need to understand consistently the voice of the customer, and we need to understand when it changes, so that we can change with it. So that we don't do something that is non-value added to the customer and us. Other types of overprocessing could be, like we saw in the first data video, it could be sorting. Multiple sorting steps. In every silo we sorted because, again, they were individual segregated silos. They existed in and amongst themselves. It was a little click that again, the compliance department says, well, we're not the same as the order entry department. They don't do things like we do. We have to have it sorted this way. So they bring it into us, and we have to sort it to make our process flow effectively. All right, and that sounds kind of lean, right? It sounds kind of like lean thinking, the understanding of flow, etc. But it's not, because we're broken up into these silos, or we're a broken link of a chain. This is a pretty funny example of overprocessing. So I graduated college at East Carolina University in Greenville, North Carolina. I now live in Fort Smith, Arkansas. I believe that I am the only East Carolina fan in the whole state of Arkansas. So I decided I would represent for my alma mater. So I called up the Alumni Association, told them or asked them to point me to some places where I could get decked out in all the ECU swag. Bought or rented a table at one of the local sports bars for my family and my friends, and they were all decked out in their Razorback reds. East Carolina was playing the Razorbacks that day. Again, Razorbacks are the team of Arkansas. So I got this box in the mail. I opened the box. It was a pair of athletic pants, obviously very fragile. Must be because they came with styrofoam peanuts in a very hard box. So obviously they're not fragile. But you look at this and you go, why did this happen? Did the company, the people in the company kind of do this mindlessly? Were they really thinking about what they're doing? Or were they just a number in the crowd? And actually, I found out that yes, this company, their employees are employees. Nobody ever listened to their employees. Employees came in, did what they're told, and left. And that's not a lean organization. In a lean organization and Six Sigma organization, we're a learning organization where everybody in the organization is expected to identify waste. So if I'm that person in the shipping department, I'm going to look at this and go, why am I doing this? This doesn't make sense. Are we doing this for a purpose, or is this a waste? Is this kind of the way we've always been doing it? And so we actually come to find out. I've worked with this company now. That now we have those processes in place, and this process was actually it was done that way, for a long time, and nobody really thought to change it. And the last waste, the eighth waste, the +1 waste, again, underutilized employees. When we say underutilized, we mean skill that we don't utilize. We mean capacity that we don't utilize by having one person only know one thing. All right. So in a lean organization, again, we're considered dynamic capacity. So I teach you, we teach you, lean teaches you, the organization teaches you that you should know many things, so that when I have freed up capacity, I can then flex. I can move around so that at the end of the process, my product comes out in tact time. My product it exits the process in tact time. It meets tact time. And again, tact time is that amount of time that I have to do something over my customer demand. Actually, customer demand over the amount of time. So that if I've got to create 3,000 widgets in a day, I can break that down to how quickly should I produce one widget, and that should give me the heartbeat of my process over time, so that the last minute of the day, of my work day, that we create that very last widget, and we keep the process balanced throughout. We don't ramp up, ramp down, ramp up, ramp down, but we keep it smooth and steady throughout the whole day. All right, and without having employees that understand how to flex back and forth, to a preceding step or to the next step down the line, in order to kind of keep the process flowing smoothly. When everybody just knows how to do their own thing, if they just knew how to do their own thing, that we can't have this flow. You have to be able to understand how to do multiple things, how to flex. And when you start understanding this, it's an amazing transformation. Benjamin Franklin once said, "The only thing more expensive than education is ignorance." I engage companies every day that have finally come to this realization. This is the point in which these companies start to transform. By completing this module, you have taken a step towards transforming your future and your success. If you have questions or comments about this module or any of the contents, please post them to Twitter or Facebook with the hashtag SSDSI, or you can also call, text, or email me directly. For those of you who are pursuing your Lean Six Sigma White Belt certification, let's go over the requirements. To become formally certified as a Lean Six Sigma White Belt, you must complete all 4 of the Lean Six Sigma White Belt modules. You will also be required to complete a final exam. This exam will be comprised of 20 questions with a passing grade of 75%, or 15 out of 20 questions correctly answered. You will have 40 minutes to complete the exam. Once you pass the exam, you will immediately get access to a formal Lean Six Sigma White Belt certificate. To register for the exam and the immediate issuing of the Lean Six Sigma White Belt certification, upon successfully passing the exam, please browse out to the link provided in the slide. If you're accessing this course through YouTube, then the link to register for the course is in the notes below. You can click any icon that resembles a lowercase I that is inside of a white circle in the upper right hand side of this video. This icon is also a link to the registration page. If you're accessing this video through YouTube, please like this video by clicking on the thumbs up and leave us a comment. Thank you for attending our course, and we hope you will continue with our other informative courses.